True. Always true. True. Always true.
Good afternoon, everybody. It's 3 p.m. Let's see. Get ourselves a little bit sorted out. I'm a little bit discombobulated. Not too bad, but just a little bit, making sure I'm getting everything squared away and ready to go. So today is probably going to be a little bit shorter because we have kind of a short lesson today. So today's lesson is on references. Now, according to the video, it's 33 minutes and some change. It's like half an hour. So depending on how much practical stuff there is, that probably means this one's only going to be about an hour long before we finish chapter 9. But then, once we finish chapter 9, we're just behind the hump. Well, because this is only, I say only, but it's 19 chapters long, this video. So once we finish chapter 9 and start on chapter 10, that is the midway chapter. So that'll be pretty exciting. Anyways, I'm pretty excited to get into this. I'm still not 100% on using the heap. I don't quite understand it yet. It is like I think I kind of get it, but it's not like I'm not super comfortable with it yet. We'll hopefully we'll continue to as we continue to learn, we'll get more comfortable with it. But yeah, anyway, so like I said, today is probably going to be a little bit shorter, maybe like an hour long. Maybe a little bit more depending on how much practical stuff. All right. So with that out of the way, let's get into the code. Oh no, I forgot to fucking get my stuff all squared away. Okay, gonna get like this, and then we gotta. So that one's good, and then we gotta get this one on this. That's good. Okay, let's go.
And you should use them when that helps whatever it is you are
This is the
designing.
end of the last chapter.
Welcome to this new
All right.
chapter where we are going to be talking about references.
Yes.
References are a way you can set up aliases for your variables and have other variable names you can go through to modify that same variable. For example, here we have a variable called var. It is an integer. It lives at this address here, and the value inside is 33.
Okay.
If we set up another alias to it as var alias, we can go through this var alias variable and use it in pretty much the same way we use the original variable. And this is going to come in handy in many situations, as we are about to see in this chapter. We are going to start in the next lecture.
That's
and
interesting.
See how we can declare, initialize, and use references in our C++ applications. Go ahead and finish up here and meet me there.
I mean, that in concept that doesn't sound too difficult. I'm curious as to why you would want to do that, though.
Again, a reference is an alias variable that you can use to reference.
It's like assigning two variables or two
that reference in pretty
different
much the same way you use the original
names for the same variable.
Let's see how that can work in C++. Here is a simple example. We have two variables. One is an integer. We have 45n. The other is a double. We have 33.65n. We want to set up references to this variable, and the syntax is ridiculously easy.
Is it?
The int value, its reference is going to be something like int ampersand. You put the ampersand symbol, you say the name of the reference, and you initialize this with the value in the variable that you want this to reference. So reference to int value is going to be referencing our integer here, and we can use this name to reference this variable here, and it is going to be like we are using the original variable, which is int value here. You're going to see.
So I'm kind of curious as to why we would want to do this. Like, I understand that we can do this. Like, this is, I think this is int. So this is, so I'm curious what this syntax is supposed to mean, because the ampersand, when we've used it before, has meant address. So it almost seems like pointers, but instead of pointers, it's something else. So int and then it's reference to int value 1, so that's this one, and then it's initialized with this name. So like this is the new name, or this is the name, I guess, for the for this reference, and then this is the value that we're editing, I guess. I'm curious why we would want to do that instead of just editing the value directly. Anyways, let's
see how this works in a minute. We can do the same using assignment initialization, and down here you see that we have an example for the double value, and we have a reference to it. Once we have these references, we can use them like we use the original variables. For example, if you come here, you see we are printing stuff out. If we print
you're printing a lot of stuff.
The value printed out. If we print double value, we're going to get the value printed out. We can also print through references. You're going to see that they are going to print exactly the same value as we have in the original variables. But the interesting thing is going to be that if you print the addresses through the original values and print the addresses through the references, you're going to get the same addresses printed out, which is really going to say these two variable names are almost exactly the same thing in C++. And this is really cool.
So they reference the same place in memory, which makes sense.
Variable name in your C++ code. We're even going to try and go through the sizes and print them out, and you're going to see that they are going to be exactly the same thing. And we are going to see how important this can become in C++ code as we go through this chapter. Okay, now that we have the reference declared, we can go through that and modify the value. And if we do that, the changes are going to be reflected in the original variables. And if we print stuff like this again, we're going to see that the changes are going
This
to be
just makes me
reflected
wonder
in the
why we wouldn't
original
use the original
variables.
value.
Okay, if you modify
Or variable,
the
I should say.
original variable, the changes are also going to be reflected in our references, and this is exactly what we would expect from our references. Okay, so this is really all there is about references. They are aliases to your variables, and you can use them pretty much the same way you use your variables. Let's head over to Visual Studio Code and see some of these things in action. Here we are in
let's see.
our working directory. The chapter is references, and the lecture is declaring and using references. We are going to grab our template files here, and we're going to put them in place, and we are going to open this in Visual Studio Code. We are going to set up an int variable. Let's call this data or int data. This is going to be much more descriptive, and we're going to initialize this with a 33. Why not? And we're going to do a double and say double data, and we're going to put in a 55 in, and we're going to set up references to these variables. And again, a reference is an alias that you can use in pretty much the same way you use the original variable. So we're going to set up a reference to int data. We're going to say int reference, mean reference by putting the ampersand symbol here, and we're going to say ref int data, and you initialize that with the variable name you want this reference to reference. And here we want to reference int data, so we're going to pass in int data, and this is going to be it. Our reference is declared. We can do the same for double data, so let's do that. Double, and we're going to say it's a reference. We're going to say ref double data, and we're going to reference double data here. So let's do that. Okay, let's bring up our terminal and see if we can compile this code here. We're going to compile with GCC like we always do, and let's close this thing on the left because it takes up some of the space here. The bold is good, so this syntax is valid C++ syntax. So what we can do is read values from all these things and show you that they really are the same things. So we're going to print stuff out, and I am going to put here some code, and I am going to come back when I have typed this. I don't want you to suffer watching me type these things. Okay, here I have the code typed out.
I don't want you to suffer watching me type these things, but I have to type these things. Otherwise, I'm never gonna see it. Data. STD inline. Okay. Do like this. Oh, wow. I did not mean to do that. Let's, here, we'll do like this. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Then we can do, let's change all of these things so that they are the relevant, correct things. So we got our address, and then we do double, and then this one is double, and then this one is address double, and then this one is address double, and then this one is our, so then these are our references. So this is ref int data. This is address ref int data. This is ref double data, and this one is address ref double data. There we go. And then we got to change these. What if I just change it so that it's, what if I do like this? Ampersand, and this one is ref double, and then this one is ampersand ref double. So that should be correct. So we have our ref double, ampersand ref double, ampersand ref int, ampersand double, double, ampersand int, int. My God, that was so much things that I had to type.
And you see that I am just going to print data through the original variables. I am going to print the actual data and print the address of the variable, and do the same for the double data, which is of type double. How convenient. And we're going to print references. We're going to print the reference and the address of the reference, and we're going to do the same thing for our ref double data here. Let's try and build this with GCC.
All right, let's
So
build it and run this
that.
shit.
And we are going to clear. The build is good. And run rooster. If we run rooster, you see that. Let's put a separating line here so that we see the entire thing. So I really like to see my things easily. So let's do that and build again. Okay, the build is good. We can clear and run rooster now. And we're going to see the original data. Int data.
So these are our originals, and then they are pretty much just copied with our references.
And this is the address.
Because this is our int data, and then this is our reference for int data. This is where that is in the address.
Really is like we are using the original variable, and this is really cool. It can allow you to pass
this is interesting,
much easily
but
using references.
I still don't understand why we would want to use a reference instead of the original.
This data, for example, to some other file or some other function, you're going to be affecting the same data. Okay, so you're not going to be making copies, and we're going to see how cool this can be, especially when we get to working with functions. This is going to be super cool. Okay, now we have seen that the references are really referencing the original values. Let's try and modify the data through the original values and see that the references are going to pick up the changes. Let's do that. We're going to take int data and change that to 111, and we're going to take double data and change that to 67.2. Why not? And after we do this, we're going to print data again. So we're going to grab the code here and use that again here, and we should see the same changes applied. So we're going to build with GCC. The build is going to be good, as you see here. And if we clear and run rooster, we are going to see that the value is 55. Let's put a separation line in here. This is cramped, and it is really hard to see what is happening here. So I am going to put an stdendl in here and build again. So let's do that. And the build is good, so we can clear and run rooster again. And now we see things separated out, and it is easier on the eye. Here we have int data to be 33 and double data is 55. And we are going to print our references, which are going to pick up the same things, because a reference is really an alias to the original variables. But if you go down, you're going to see that the data has actually changed. Int data has changed to 111. And double data has changed to 67.2.
Yeah, it's changed, and it's still at the same address.
Have also picked up those changes because they really are referencing the same things in memory. It's like we are using the original variable to read these things like we are doing with references here. And this is really cool. Here we have used the original variables to modify data, but we can also modify the data through references, and the original variables are going to pick up those changes. So let's do that. We're going to say ref int data, and we're going to change this to 12, for example. And let's use 1014 or 12. This is going to do. We're going to do ref double data and put in another large number, let's say 1000.45. Why not? And we're going to print the data again. So we're going to grab this and print stuff out again. So we're going to go down and put in the code to print stuff. And you see it's going to use the original variables and the references, and we should see the changes reflected in our terminal here. So let's do that. And we're going to build with GCC as we always do. The build is going to be cool. We're going to clear and run rooster. We're going to see that we have 33 and 55. The references are going to pick that up. That's what we have here. We're going to put in 111 and 67 through the original variables, and the references are going to be picking that up. And we're going to use references and modify data. You see that the original variables are also picking that up because we are really modifying data in the same memory location. That's why these changes are being shared between references and the original variables. And this is really all we set out to do in this lecture, to show you how you can set up a reference and prove that the changes we do either through original data or references are reflected between these two guys, meaning references and the original variables. We are going to stop here in this lecture. In the next one, we're going to do a comparison between pointers and references because they seem to be doing quite the same thing. Go ahead and finish up here and meet me there.
I don't know if references and pointers, I don't think I'd say they're doing the same thing. They just kind of... Pointers seem to have a different function, and they're more about addresses, specifically. But, like, with references, I'm still a little bit confused. I'm not quite sure why we would choose to use a reference. Like, why would I... Like, it's one thing, right, to change the value of a given thing, right? Like, up here, it's initialized at 33, and then we change it to, we assign it 111 later. But why would we bother doing that through a reference? That's kind of what I'm not sure about. It seems like a very roundabout way of accomplishing the same thing to me. Like using ref int data is functionally identical to doing int data. I mean, like if we were to here, if we like if I do this, does this there? Like if I do all of this stuff, if I like fucking make a pointer and we call it just, and we do it like this. I guess this one doesn't work. Well, like, oh, because this is because this is a reference. I guess you can't point at a reference. Let's see, can I? So I can't do this. Cannot be used. What if I just do int data? Cannot be used to initialize. Oh, wait. No? Type name is not allowed. Wait, what am I doing wrong? What the hell? Uh-oh. I might need to review pointers. I don't quite understand what I fucked up here. I still don't understand why we're doing references. Like I don't know what the purpose of them is. Why we would choose to use them. Okay. Let's go on. Open. Okay, we're gonna go ahead and uncomment this stuff. And then we'll do, I think we'll probably end up just commenting this whole thing out.
In this lecture, we're going to be looking at the similarities and the differences between references and pointers. Okay, we know that a pointer is really something that is going to store the address of a variable, and we can go through that pointer and modify the original variable or really do things with it. But in the last lecture, we saw that we could also do the same thing with references. So why have these two mechanisms in place, and what are the differences between them? Here is a simple slide that I put together to put the important points about references and pointers together. The first thing is that if you use references, you are not going to go through the star symbol to the reference and get to the value you are manipulating. So that's going to really feel like you are using the original variable. But with pointers, you are going to go through dereferencing. So that's the first difference. Another thing about references is that you can't change them to reference something else later. But with pointers, we saw that we could do that. We can change a pointer to point somewhere else if it happens to be a non-const pointer. The other thing is that for references, you have to initialize them at declaration. You can't declare a reference and not initialize that. If you do that, you're going to get a compiler error, and we're going to see that in a minute. But for pointers, you can declare a pointer and not initialize it, and it is going to just contain a junk address. And if you try to use that uninitialized, you are going to be setting yourself up for trouble. So we saw that.
Yeah.
So these are the main differences between pointers and references. And
It
now
seems to
we
me
are
like
just going to be
references are
looking
just
at how these
kind of
translate in code.
very,
Here is a simple example. We have a variable called
Oh,
double
I was
value,
forgetting
which
the
happens to
ampersand.
be double,
Whoops.
and we have a reference to it and a pointer to it. So you already know these concepts. Now, if we want to read the value in here through our pointer and references, we're going to be using two different syntaxes. If we go through the reference, we can use this reference variable name directly and read the value or change it. And we can do something like ref double value to print that out. This is going to work. But if we want to go through the pointer, we will have to go through the referencing. And this is really bad.
Right.
You know, sometimes people don't like this syntax. They think that it is not direct enough. So they prefer to use references to do these kinds of things. But pointers are still important, as we will see later as we progress.
Pointers just seem more
So this is one difference.
flexible.
With references, you don't have to go through the dereferencing mechanism to use this star here to print stuff or even manipulate the data inside. You just use the variable name and it is going to work. With pointers, you have to dereference, because if you don't dereference, you're going to be referring to the address stored in this pointer. This is the first difference. And we see that the same applies if we are trying to write data into our variable. If we go through the pointer, we will have to dereference and use the star symbol in front here. If we are using a reference, we can do that directly as if we are modifying the original variable. So this syntax
It's
is
still
much more readable. The other difference is that
I mean,
we can't make a reference.
the syntax is more readable, but I still don't understand why we would do that over just editing the original value. Like if that is functionally what we're doing, why are we using a second name for the same thing? Like, can I say, like, the way this is set up, right, makes me think that we could have multiple aliases for the same thing, right? Like we have our int, and then we can create a reference. Like, here, let me try that real quick. Can I create another? Can I create a second reference? If I do int ampersand ref 2 int data, and then we do int data again. It looks like we can do a second reference for, and I don't know what the purpose of being able to do this does when I could just as easily be changing this, or whatever whatever here. That's kind of like he mentioned that it would be helpful for some people or for some purposes, but I don't know what those purposes are, and this just kind of seems pointless at the moment.
Reference something else, but we can change a pointer to point to something else. Let's look at an example here. We have ref double value, which is a reference to double value, and here we are doing an assignment to this thing here. We are saying either double value and assigning that to our reference. But what we are doing here is not making ref double value reference this other variable. We are just grabbing the value in other double value and assigning that to our reference. And the value in other double value is going to be reflected in the original value here. So this is what we are doing.
Yeah, so
we are not reassigning to our reference to make it reference something else. We are assigning the value to the reference as it is now.
So,
And it
but
is
why
going
would
to
you
be
want to do
still
that?
referencing the same
I
variable
don't
in
understand.
memory. If you print out the address in memory, you're going to see that the address of the reference here hasn't changed. So this is something you should keep in mind. But we know that a pointer can point somewhere else. If we have a pointer here, for example, p double value, we can reassign it another address and make it point to that new address. So in this regard, we can think of references as const pointers because const pointers can't also be made to point somewhere else. And if you're trying to do that, for example, here we have a const pointer. It is called const p double value. And if we try and make it point somewhere else through this assignment here, we're going to get a compiler error.
Yeah,
okay, so
we showed
this
that
is really
before.
all in terms of the comparisons that we had to make between references and pointers. Now we're going to head over to Visual Studio Code and see how these things work in real code. So here we are in our working folder. The current project is comparing pointers and references. We are going to grab our template files and put them in place. And we are going to open this project in Visual Studio Code like we always do. We are going to go down and put in some starter code. And let's align this a little better. So, and we can close this pane so that we have some breathing room here.
All right, let's copy some of this stuff. So we're going to go ahead and copy just like this. And we're just going to change some of the data. So we're going to have our okay, so we got our, we're going to make our stuff. First of all, let's make our stuff work. Double value, we'll call this 12.34. And then we're going to have our double reference, ref double value. And it's going to be a reference to double value. And then we have our pointer. And this will reference, or this will point to, rather, double value's address. Okay, so then I have to take this, go to double value, and this one will be ref double value, and then this one will be p double value, and then this one will dereference p double value. So we're going to get all of these things. And this one's just going to be double value. And then this one is going to, so this is first, he has it written as reading. I'm going to say it's our first pass. And I'm also going to go ahead and copy this so that we can see the end of the line. Actually, I'll format my stuff a little bit. Do this. So that's first pass. So this is our first pass. This is where we essentially see all of these things and confirm that, confirm what we know. So here it's like, okay, this is going to be, this should print out 12.34. This one should also print out 12.34. This one should point out the address that it's at. And then this should point out 12.34 as again. So then the next one we have, this one's writing through pointer. So then here we change p double value to 15.44. So because we've done it this way, this has dereferenced it, and we're not because we've written this in. This is not affecting the address. This is affecting the value, the thing in p double value. So this, we're affecting this address, which is this value. So we're rewriting this to be 12.34, and then we're printing all of this again with the new value. That seems to be what we're doing. So all of the address, or I say all of this line should be completely unchanged. It should be exactly the same as the first time that we saw it. But now all of these different things should print out 15.44 instead of 12.34. Let's go ahead and just run this real quick. 12.34, 12.34, this address, 12.34, and then we've changed it to 15.44, 15.44. The address is still exactly the same, and then another 15.44. I assume that's what he's going to do in the video.
We have a variable of double type, and we set up a reference to it and a pointer to it. This is how we do this, thanks. You already know this. And we can try and read through the original variable, through the reference, and through the pointer, and see how these syntaxes differ and how one might be better than the other. For example, if we look at how we are using the reference, it's really like we are using the original value here. We don't have to dereference. If we try to print the pointer directly like this without dereferencing, this is going to print the actual address stored in this pointer. It's not going to print the actual value stored in the address pointed to by this pointer. I really want this to be clear. So this is the syntax we can use for reading stuff, either through references or pointers. We can also use these syntaxes to write stuff into our variables. For example, here we can go through the pointer and we have to dereference, and we can go through the reference to really do the same thing. And we're going to see that our syntaxes here are going to pick up the changes regardless of whether we write through pointer or a reference, because all these things really are going to be referencing the same location in memory. Let's try and bring up a terminal here.
Yeah, and then this is the exact same thing, but with ref instead of pointer.
The build is going to be good, and we're going to clear and run rooster, and you're going to see that at first we're going to have a
same address,
0.34 in
new value,
that's going to be the value. We can get it through
pointer,
original
new
value
through
reference, or the pointer through the referencing, and the address is this one here. If we change the value through the pointer, we're going to see the changes reflected here. And if we change the value through the reference, we're going to see the changes reflected in here. So this is how you can use pointers and references to do these things here. And you can really choose what makes sense for your application. They mostly do the same things. But some people say that the syntax to dereference the pointer here is really ugly. That's why most people prefer to use references like this. But references have other benefits as well, as we're going to see as we progress in the course. Another thing I want you to see
I hope so, man, because as we are,
something else in memory. For example, here we have our reference, which is ref double value. If we try and make it reference something else, we're not going to get that result. Let's go down and try to do that. So we're going to set up another double variable. So if we try to make our ref double value reference this guy, the syntax that comes to mind is saying ref double value and assign that some other double value here. Now
that is not what comes to mind for me. So let's see. Hold on. I'm gonna see if I can figure this out. So we're gonna create our double some other double 78.45. Okay. So we want to change this reference, ref double value, and we want to change it, make it reference this value instead. So what he put is that it's... What he put is like this, which I guess kind of makes sense, but with the way that we have it done here, we know that this just writes a new thing. And since this is another variable, it's just going to be like this. What I think we need is the address. It seems like it doesn't work. Assigned to value type of double pointer cannot be assigned to entity type double. Let's see. So this is our ref double value, and then it's initialized to this. We know ref double value is already a it's a reference, right? So it doesn't work to just... So this doesn't work. This doesn't change what it's referencing. Can you change what it's referencing after the fact? Some other double. We can change the value of it. Oh, fuck. How did we change pointers? Because we could change what a pointer is pointing to, right? But I guess that was because we created this, and then we were able to just edit it. Can we just... Ooh, you got to pointers? We did pointers yesterday and the day before. Currently we're doing references, and I'm trying to figure out, before he actually tells us, is it possible to change what something is referencing halfway through, or like after we've declared it? And I would imagine that it's possible, because you're able to change what a pointer points to. I mean, there was a whole point on that with like trying to avoid null pointers and shit like that. Like, you don't want to use something that is pointing at nothing, because that's just a garbage address or whatever. And he said, so what he said is that this is the syntax that might come to mind if you're trying to reassign your reference and change it. But since we know that doesn't work, because that's literally just writing to the reference, this does not like, because this is our new double. So then the syntax he's demonstrating is identical to this, which we use to write the value through the reference. So I'm not 100% on how we could change this. I'm tempted to say it's something like this, but it doesn't seem to take. And it doesn't seem to like that. It's expecting a semicolon somewhere, apparently. Yeah, let's continue.
Happens if we do that? We're going to try and print whatever we have in memory using the ref double value here. Let's grab this and go down here and say that we are changing the reference, making the reference something else. Let's say that. So if we try to build this, let's see what we get. We're going to run and build with GCC, and we're going to try and run this clear, not clear, and we're going to run rooster. We're going to see that
Yeah, he just wrote it a new thing.
78.
Didn't actually make it reference something new.
But the address is still the same. So we are still referencing the same memory with our reference, and what we just did here was just grab the value in some other double value and assign that in here. But the reference is referencing the same memory location it's been referencing. So in C++, you don't have a way you can go through to make a reference something else.
Wait, you
The
just
only
actually
chance you
can't? That's just like a, oh, yeah, sorry, bud, you can't do that. What?
have to make it reference something is through declaration here. And that's the
Hmm.
reason you can't declare a reference and not initialize it. If you do that, you're going to get a compiler error. So let's try and do something like this. We're going to take out this double value. And the moment we do this, you're going to see that Visual Studio Code is going to be unhappy. You see the squiggly line, and it is going to say initial value of reference to non-const must be a null value. So what is that?
If I recall, both pointers and references are immutable. Well, no, wasn't pointers well, pointers you could change what something was referencing to, or what it was pointing to, by like you could like change it to null pointer. And because like I think it was like if you use a, like in the last one, in the last lessons we were learning how to use the heap using like new, and it was like you would if you assigned a pointer in there, you needed to then, like after you have released the memory, you need to change the pointer to null pointer, so that it's not referencing garbage data anymore. Because if you release the data, if once you use delete on whatever section that was, it needed to be changed back to null.
Okay, if we take out the initialization altogether, it's going to give us a better error. I think reference variable requires an initializer. So every time you
Interesting.
declare a reference, you have to initialize it. And we should do like we just did before here, and we're going to be fine. Again, you can't declare a reference and not initialize it. If you do that, you're going to get a compiler error. And the reason is that this is the only shot you got to make your reference something else. Okay?
And I
If there
still
was
don't
a way for
understand
you
why
to
we would want
bypass
to use a
this
reference instead
and
of
let the
like just
compiler
editing the
compile
original
this,
value.
you would never get
Because
another chance
functionally,
to make
it's
this
doing the
guy
exact
actually
same thing.
reference something, and it would really be a useless reference. So make sure you understand this. You can't make a reference something else. And if you try to do something through a syntax like this, you're going to be assigning the value of whatever variable you have to the reference. You're not going to be making the reference referencing something else. The reference is going to keep referencing the same variable in memory as we have seen here. So let's say what we were trying to do here, but we know that we can make pointers reference something else. So here we have a pointer again, this pointer called p double value, and it has the address of double value inside, but we can set up another variable. Okay, so we can make that reference this other variable here, and let's do that. You're going to see that our pointer now is going to be containing another address. So what we can do is say p double value, which is our new pointer, and we're going to assign it the address of some other double value. And if we print the data now and go down, we are going to say make the pointer point to something else. That's what we are doing here. And we're going to say the same thing here through a comment. And if we print
Oh god, I deleted some shit and I didn't pay attention.
this, try to guess what we're going
P double value. What did I fuck up? I fucked something. Oh, I know what I fucked. I didn't put a fucking thing there. Yeah, we're gonna get this thing. Put this back in here. Because if we do ref double value equals some other double. We're gonna change. We're gonna add some lines here. So this, do it up here. This changes ref double value to this simply writes some other double to the. I'm just gonna say this simply overwrites the data. Does not change reference in memory. Yeah, because that's all it's doing. It doesn't actually. This thing here will be the same on 1, 2, 3, all 4 of these slots, which means that your reference is still referencing the same thing. Whereas with this, the pointer will change.
We're going to get. The pointer is going to contain a completely new address. Because we can do that, we can make it point to somewhere else.
We're
Let's
supposed
run
to,
roster,
anyways.
and we're going to see our.
Did I fuck it up? Because we have our. So we have. First things first. We have our 1234, 1234. And then we have the place in memory that it's referencing. Oh, you know what I fucked up? You know what I might have fucked up? Hold on. So, going through each line. So our first pass, come to here. These ones are exactly the same. This is the place in memory that it's stored. Here, we overwrite the data. It's still at the same memory. Here, we overwrite the data again using the reference, and it's still at the same place in memory. And then here, with 73, where we try, quote unquote, to overwrite the memory or to change what the reference is referencing. But all we're doing is overwriting the data again. It's in the same place in memory, and then this one is actually changing what we're which place in memory we're pointing to. As you can see here, I mean it's really similar, but E8 and E0 are not the same thing.
Data here, let's make sure we see the entire thing. Okay, I think this is the data we have. Let's go up again. There's no harm in that. So we have our things that we have seen before, but what is going to be important here is that P double value now contains a new address.
Yes.
Okay, so this is really important, and you have to understand that. So we made the pointer successfully point to something else, and if we change the data in the pointer now, we're not going to be affecting the data we have in here, in double value. We're going to be affecting the data.
Yeah, now, I mean, he's going to say this exact same thing, but now if we change the, now if we try to use this and write through dereference again, or this one, and we write through pointer, now when we edit here, let's just take this again. Now when we take this after this point, do it like so, change it to, I don't know, 26 point, or 23.84. We do like this. This one will have exactly the same address, but then it'll change it'll change the values here. It should. Or no. It shouldn't change these values. Like this last line should get printed exactly as is a second time because we're not using some other double anywhere. And this is not necessary. P double, wait, what? This changes what the P double value pointer is pointing at. This changes the value inside of some other double. So then this number should get changed to this in this next line that I've created. So we'll run this real quick. So what should happen is that the second block should be pretty much exactly the same, both 2 times. So here you get all of these, 15.44, 18.44, and then we have this one. So we have the last. Yeah, so here we tried to change the some other reference, and it didn't work because that's not something that you can do. And then this one has the same text but changes this point in this line of memory. And then the only one that actually changes is when we dereference p double value to the 3.84 that we had before.
Data we have in some other double value here. Let's do that. We're going to change the data through the pointer, so we're going to say p double value, and we're going to change this to 555.5, and now we can print the data and see that things have changed in memory, and we can print this to see the differences here. But before we do that, let's also print the address of the original variable and the address, because for now we are just printing only the address through the pointer. So what we can do here is grab stdc out and say address of double value, and we're going to put that out through stdc out. Okay, we're going to do that, and we're going to print the address of the reference. Why not? Ref double value, and we're going to put that out as well. Yeah,
he's putting a couple of extra things in that I didn't.
Value,
but functionally or fundamentally, I understand the same.
We are going to grab the entire thing here and print it out after we modify the value in the pointer. I hope this is going to show things in a much more clear way.
Honestly, I should probably just comment most of this out.
The build is good, so let's clear and run Rooster. And what you're going to see is that now the original variable is living at address here, which we can see in our reference, but the pointer now is pointing to something else. No wonder that the changes we did through the pointer are not being reflected in our double value, because these two variables now are living in different memory
Just comment
locations.
everything, that way
really
it will
hope you
compile
see
for
that.
sure.
And this
It
is
does
really all
compile
we
for
have to
sure if
share
you
in terms
comment
of
everything.
the
It doesn't
differences
do
between
anything,
pointers
but it
and
does
references.
compile.
I hope you have a clear picture of what these two things are, and we are going to stop here in this lecture. In the next one, we're going to see how the const keyword works with references. Go ahead and finish up here.
Oh boy.
And meet me there. In this lecture, we're going to see how the const keyword can be used with.
Here, I am going to comment all of this out though, because I was planning on using a single document for today, because today is supposed to be a little bit shorter, but now we're doing references and const here.
And again, the idea is to set up an alias to a variable and make it const so that we can't go through it to modify the original variable. This is the syntax we use.
That's actually helpful. I could see how that is useful.
So far. So for example, we can say int age, put in a value 27 in this case, and set up a reference to age and initialize that with the age variable. Once we do this, ref age can be used to modify this age variable here and whatever is inside. For example, we can go through ref age to increment the age, and if we print the age now, we should get a 28 printed out, because this reference is going to change these two things at the same time. Or another way to say this, these two things, age and ref age, are referencing the same memory in your computer. So if you change one, the other is going to pick up the change. We can also set up a const reference, and the syntax is ridiculously easy. You say const int reference like this, and your reference is suddenly const, and you can't go through it to modify the original variable. If you need something like this in your application, this is how you do it. You can also duplicate the behavior with const references with pointers, and for that we can use a
Const
construct
references.
like const and pointer const. This is going to set up a const pointer to const, which we can't use to modify the value that we are pointing to, but it can't also be used to point to something else. So this is going to simulate the behavior we have with references. And you can do that if you want. And please know that we have no such thing as const int reference const. This is going to give you a compiler error because we have no such concept in C++. And my head is hurting right now trying to think about what this would even mean. And another thing I want to make clear before we head over to Visual Studio Code and play with us is that the const keyword is going to apply to the variable name that you apply it to. For example, here we have const reference age, which is going to be a const reference, but this doesn't mean that the age variable here has to be const. Okay,
Yeah, because it's
const,
just
or
the...
it may not be const, but the const here applies to this variable name, const ref age, and we can't go through this variable name and modify the age. If you're trying to do that, we're going to get a compiler error. Now we can head over to Visual Studio Code and play with us. Here we are in
that sounds simple enough to
working
understand. You
directory,
can
the current project.
So const references allow you to use the number without accidentally updating it. Like if that's not something that you're planning, that you're trying to do, like you're not trying to change, like with age, right? You might want to increment it once in a while, but you probably don't want to change it too much.
Project is reference and const. We're going to grab our template files pretty quick. Let's do that. And we're going to put them in place. And we are going to open this in Visual Studio Code. We are going to review the references we have seen so far in this little example here.
Oh boy.
We have the age variable. It has a 27 inside and it is a net. And we have a
All right, let's go through, we're gonna have to put this stuff in. STD and line, and then we have STD cout non-const reference STD and line. Then we have our int age, call that 27. Oops. And then we go int reference ref age, and we're going to have it be age. So then we have std cout age, and then it spits out the age, and then we have std cout ref age, and it should do the same, ref age. So for this one, because so for this one, because of the way we've written it, we can change the original variable through the reference, just like we did in the last example. So here we have std cout, another line, and then we do modify original variable through reference. Then we do ref age increment, modify through reference. Then we have our std cout, and it's basically just spitting out the age again after we've incremented it. I almost wonder if we could just do ++ ref age and then print age afterwards. That probably works, but it's I don't think it fits as well for the example. Ref age, ref age, and then we end the line. So what this does, I'm going to clear this real quick. What this does is very simply, we have our non-constant reference. So we create our age, and then we have the reference to the age, and then here we spit out the age, which is going to be 27, and then the reference age, which is also going to be 27. And then here we're using the reference to modify the original value again. So we know that we're able to do this. So let's go terminal, run task, and we'll just run it. Yeah, and they're incremented by 1. That makes perfect sense.
Reference to it. And this reference is not const. So we can go through this reference, modify the age, and if we
presumably,
do that, this is
the
going
way
to
that I'm
work.
understanding
If
this,
if
we do this as a constant,
into
constant,
28. And we can try and print this through the terminal so that you
const
can see
reference.
this for yourself. So let's run the task to
const
build
int
with
reference.
GCC. We are going to clear.
We shouldn't be able to
and
do
run
that.
Rooster.
It shouldn't work.
And if we do that, you're going to see age is 27, now it is 28, and we have successfully modified data through our reference here.
Right.
But if we change this reference to be const, we won't be able to do that anymore. So let's try and make it a const reference. If we do that, we're going to get a compiler error if we try to do something like this. Because this is now a const reference. We're going to go through it to modify our data here, and we're going to get a compiler error. Here we have Visual Studio Code complaining here, but if we ignore that and go through the compiler,
it just doesn't work.
We're going to see that we get the same compiler error. We can't implement a read-only reference, which is this ref age here.
Yeah.
So this is what a const reference really is. You can't go through it to modify the data that is being referenced. And another thing I want you to really understand is that this const keyword here has nothing to do with the original variable. This is a const reference. We can't go through it to modify the age variable, but this doesn't matter if age is either const or not const. The constness here applies to this variable name here. So this const age may be const. If it's const, it's going to work equally well, and we're going to still get a compiler error here. If it's not const, it's going to be the same. The const we have on our reference applies to this reference variable name here. This is what I want you to understand. Okay, this is what a const reference really is.
Oh,
another thing we want...
That's not something that he covered. If we change this to const, but we don't have this one as const, qualifiers dropped in binding reference of type int and to initializer of type const int. So does that mean if I do const int, do I have to have a const int reference? I do. Okay. See, that's not something that was mentioned. That's pretty cool.
You to see is that we can simulate the same behavior with pointers. So let's set up a const pointer to const on this age here, and we're going to see that we can have the same behavior. But for that, we're going to have to comment this out because we don't want noise output. And we're going to go on top here and comment this out and say what we are intending to do. We can say that we are simulating reference behavior with pointers. And the way we're going to do that, we're going to say const int pointer const, and we're going to say ph, and we're going to initialize this with our age variable or the address of our age to be super clear. Okay, so we have our pointer set up. Let's try and go through it and modify the age. Let's see what happens. The reference, because this is a pointer, and we're going to say ph and say plus plus, or even change this to another age, let's say 45. And if we do this, we're going to get the same compiler error. So if we build this, let's clear here, clear, not clear, and build again, we're going to get another compiler error saying that we can't modify something that is read-only, assignment of read-only location. This pointer can't be used to modify the data in this age location here. So this is the same behavior with references. Because a reference by default can't be made to point somewhere else,
Yep,
we
must
have
be
to
a
make this
modifiable
pointer
value.
also a const pointer preventing us from making it point to other locations. So this is how you can simulate references with pointers. And this is really all we set out to do in this lecture. I hope you found it interesting. The main idea
Okay.
was to let you know how you can work with const references. And once you have a const reference, you can't go through it to modify the original data. If you do that, you're going to get a compiler error. Welcome to this new chapter.
Oh, that's another chapter. Okay, hold on. So that next one is character manipulation and strings. Okay. I'm gonna go ahead and we're gonna go ahead and save this. And we're gonna open my little thingamajig. Chapter 10. What is this? What is this? Is this the whole chapter? Yeah, character manipulation and strings. We'll call it that. So, okay. I'm going to go ahead, come to here. So, I still am not 100% sure why we would need to use references. A const reference I can kind of see the value of. But just using a normal reference seems a bit kind of... It seems like a roundabout way of just using the original thing that you are referencing. I don't know when I would want to use a regular reference instead of just using the original, because I feel like if I'm looking at the original, then I know, like, okay, this is the thing that I am changing, this is the thing that I'm modifying, and it makes more sense to use it that way than to just have a reference to that thing that I'm changing and to doing exactly the same thing with fundamentally. I'm sure there is some use for that, but a constant reference I can see where, like, if you use it, then, like, it's read only. So, like, okay, I'm using this value, but I don't want it to. I don't want it to be changed or modified by other things in this instance, but you'd use the original in other instances where you do want it to be changed and affected. So I'm not 100% sure what the use cases of them are. He made a point of mentioning pointers and of, like, showing how they can be used for similar ends, and I'm not 100% sure on uh why that is necessarily. Like, because fundamentally, I think the main difference is that a pointer seems like it's specific to memory. Like, you're doing something specific to the memory rather than to the value itself, or like the point in memory is more important than the variable. I don't know exactly why we use either of these things. I'm sure that there's a reason to use them, and I think I've mentioned before, like, the first and only thing that I knew about pointers before going into pointers, like, 2 days ago, was the fucking, like, old ass 2chan meme with, like, null pointer error, and it was like a nurupo ga, and, like, the whole point is that you're just hitting somebody who wants to shorten it that way. That is the only thing that I knew, and it's like fucking old ass fucking meme. So I don't know exactly. I'm not exactly sure how this is gonna shake out. What we're gonna do, how important these different concepts will be. I do think it's interesting that we're now at chapter 10 is the, like, halfway chapter. We're still like 1/3 into the video. We're only like a little bit less than halfway. I think 13 hours, over 31 hours. We're like a little bit less than halfway, but it's the middle chapter, so that's cool. That gives me some hope for how things are. It feels like progress, is all my point is. Anyways, I'm gonna go ahead and hop off. I'm probably a little bit before I ate some dinner, but then, I mean, it's been fun hanging out. I hope you guys have a good one. We'll be back with some more C++ on Monday. Over the weekend, I'm going to be playing some Baldur's Gate and some Warcraft. It'll be fun. I hope to see you guys there. And yeah, peace out. I will be back on Monday with some more C++. Later!